Hey everyone, coming back to electromagnetics, and over here I have come here with another question from the same chapter of the book Principles of Electromagnetics, first chapter, that is Coordinate Systems and Transformation. Okay, this is the question which goes like this: that you have been given a vector over here, that is H vector, which is 4 a rho cap minus 3 a phi cap plus 5 a z cap at this point 1 comma pi by 2 comma 0, and the component of H parallel to the surface rho is equal to 1 is what you have to choose among these options. Okay, this is the question that's given to us. Okay, so what's written? The component of H parallel to the surface rho is equal to 1. Okay, first things first, when you're given a surface which is written just directly like this, rho is equal to 1, okay, then if you have to find a vector normal to it, it's pretty straightforward. You say it will be plus minus a rho cap. Okay, how did I know? How did I know this? Okay, suppose this is y, this is z, this is x. Okay, and what is my rho direction? You have phi over here from x-axis, so along this, at this point is your rho, and this direction is a rho cap. Okay, this is correct. Okay, then if it's given ki rho is equal to 1, what does this mean? This means that your rho is fixed. Your rho is fixed. It is 1. Okay, it will not change. What can change? Phi can change. Your z can change. Considering, because this the part of cylindrical coordinate system. Okay, rho phi z. Okay, where rho is fixed, that is 1. Only these two, phi and z, can change. Okay, that means you can consider it to be a cylinder of radius rho is equal to 1. Okay, radius rho is equal to 1, and it's a infinitely long cylinder. Okay, z can go anywhere up to from plus infinity to minus infinity, anywhere, but our rho is fixed. Okay, the surface is the surface is this surface. You can consider a bottle of radius r. Okay, you can consider a bottle of radius r, and the surface of the bottle is your surface that is given, that is rho is equal to 1. And if I have to say what is perpendicular to this surface, then I can say then I can obviously just go about it like this. All this surfaces wherever you take your rho, it is perpendicular to that particular surface. Okay, so basically this is 90 degrees to the surface. Okay, so this is a rho cap perpendicular to the surface. Or else, how do you calculate what is perpendicular? You take del. Okay, you take del of whatever is given to you. Okay, and you take it out. That will be your normal vector. For example, over here in this case, what can you do? You can take the del vector of this given vector like this, rho minus 1. Okay, and in this case it's dou by dou rho minus 1. Other everything else will be 0. So this you'll get a rho cap like this. So this is a rho cap. This is your vector. Okay, so in this way also you can take out that the normal vector is this. But as a general rule, you can remember that whenever it's asked that whenever you must remember that a unit vector, that a unit normal vector to a surface n is equal to constant is plus minus an. Okay, just remember this. Then what is it that it's asking? The component of H parallel to the surface rho is equal to 1. Since I know what is normal to this, है ना? I know what is normal to this surface, so I can do one thing. I can take out the component of H. Okay, and then whatever, whichever component of H is there, that is that you can get a dot product. You take a dot product with this normal vector, and if it comes 0, then that is obviously what, parallel to the surface rho is equal to 1. I hope this is clear. Basically what I'm saying is, suppose you have a surface over here and you know the normal vector over here, okay, that is your a rho cap in this case, okay, of H. You want something that is parallel H, a component of H that is parallel to this surface, okay. And since I have a vector that is perpendicular to this surface, so this will obviously be perpendicular to this component as well, है ना. So I can say that the dot product of this component and this unit vector normal to the surface will be 0, because cos 90 is 0, okay. This is pretty simple, you must understand it. Then let me write it over here. Some component of H vector dot a rho cap, I'll get 0, okay. And since you can see over here, what is it that you've got in H vector? You've got 4 a rho cap minus 3 a phi cap plus 5 a z cap. So basically, if I do a rho dot a rho, then I'll get something, it'll give me some value. But if I do a phi dot a rho or a z dot a rho, then obviously I'll get 0. So I can choose just this component of H, so that this result is satisfied. So if I have to choose a component from H vector, then I'll neglect this, which can give me a non-zero value, but I'll choose this much, which will give me a 0 value. So you can see it in the options. This option D, it's given minus 3 a phi cap plus 5 a z cap. So this will be my correct answer, because this will satisfy this equation. Okay, I hope this is clear to you. And if you have any doubts, then you can write it in the comments section. Okay, thank you. That's all for today.